Preparation methods of aldehydes and ketones from carboxylic acids. Dry distillation of calcium salts of fatty acids, let us see. In this, calcium formate on dry distillation, formaldehyde is the product. Whereas other aldehydes prepared by dry distillation of equimolar mixture of calcium salts of carboxylic acids with the calcium formate. Now let us see in the first case, that is when calcium salt of carboxylic acid reacts with calcium formate, then we'll get carbox, that is carbonyl compounds. The reaction takes place in this way. Removal of calcium carbonate takes place. Because of this, we'll get the product is RCHO plus CaCO3. 2 moles of aldehyde is formed. This is aldehyde. So here calcium acetate when reacts with calcium formate, then we'll get 2 moles of acetaldehyde, CH3CHO, same as a first one. First case reaction is taking place and their removal of CaCO3 takes place. CaCO3, 2 moles of acetaldehyde is formed. When calcium acetate, only calcium acetate is taken at 673 Kelvin, on heating we'll get ketones, that is acetone is the product, CH3 C double bond O CH3, along with this CaCO3 is formed. Next, calcium acetate when reacts with calcium propionate, same on heating, the compound formed is CH3 C double bond O C2H5. This is nothing but ethyl methyl ketone is formed along with this CaCO3. So this is ethyl methyl ketone. Whereas this is acetone. Next, let us see calcium succinate on heating will get cycloketones are formed. So the compound formed is CH2 C double bond O. So this is calcium carbonate. Cyclopropanone is the product in this reaction. Now catalytic decomposition of carboxylic acids. In catalytic decomposition of carboxylic acids, generally here higher carboxylic acids reacts with lower carboxylic acids in the presence of thoria or MnO at 573 Kelvin will get aldehydes. So this is the aldehyde. The reaction is between acetic acid and formic acid. In the presence of Al2O3, the compound formed is CH3CHO, that is acetaldehyde. Along with acetaldehyde, we'll get H2O and carbon dioxide are formed. This is acetaldehyde. Next, 2 moles of acetic acid if we take, on heating with the MnO at 573 Kelvin, the product is CH3 C double bond O CH3 plus H2O plus carbon dioxide. Here the product is acetone. Next, hydrolysis of gem dihalides. So gem dihalides on a hydrolysis in the presence of potassium hydroxide will get dihydroxy compounds, that is CH3 CH OH OH. So this is highly unstable, you can say. This is unstable compound which undergoes dehydration, that is removal of H2O takes place like this. Then the product formed is CH3 CHO, whereas this is unstable compound and this is acetaldehyde. Next, isopropylidine chloride. This is also undergoing what hydrolysis, that is potassium hydroxide is reacting with the isopropylidine chloride. Then two Cls are replaced by OH groups. Again from here removal of H2O takes place, minus H2O. Then the compound formed is ketone, CH3 C double bond O CH3. So this is acetone. Next, from alkenes also we can prepare carbonyl compounds. First one is reductive ozonolysis. By ozonolysis reactions, carbonyl compounds are formed. In the first case, alkene when treated with ozone in the presence of CCl4 at 196 to 200 Kelvin, ozonide, an intermediate, is formed which is unstable. Then this ozonide cleaves like this. Because of cleaving, we'll get RCHO, that is 2 moles of aldehyde. Along with aldehyde, we'll get H2O molecule. So here minus ZNO takes place. So this is the aldehyde. Same way, if we take this reaction, that is alkenes, ethene molecule. Ethene undergoes ozonolysis and forms ozonide like this. Hydrogen, 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 hydrogen. So this compound will cleave like this. Because of this, we'll get 2 moles of formaldehyde plus H2O. This decomposition takes place in the presence of Zn H2O as it is. Next, in the case of propene, on ozonolysis we can get two products. One is CH3 CHO, other one is HCHO. How this reaction takes place, this already we discussed in the class, where double bond is there. The double bond, just you remove the double bond, in place of that you can add double bond O, double bond O, so that your bond will cleave. One molecule is acetaldehyde, another molecule is formaldehyde. Next, the compound 2-butene gives 2 moles of acetaldehyde, 2CH3 CHO. Now you can understand that, right? So here one double bond, here one double bond. Next, in the case of this molecule, that is 2-methylpropene, one is acetone, CH3 C double bond O CH3 plus, other one is formaldehyde. Next, here 1 mole of acetone and the second mole is acetaldehyde. Here 2 moles of acetone is the product. CH3, C double bond O, CH3. This is about reductive ozonolysis reaction. Next, same like ozonolysis reaction, one more oxidation reaction is there. Lemieux reagent is used in this, same as it is like ozonolysis reaction only. So in this compound, alkenes on oxidation in the presence of NaOI4, which is called as Lemieux reagent. So this is called as Lemieux reagent, which gives aldehyde. That means alkenes on oxidation in the presence of Lemieux reagent, aldehydes are the products. Now let us see some examples. So in this case, PHCH double bond CHCH3 in the presence of Lemieux reagent, the product formed is benzaldehyde, that is PHC double bond O. Just you remove double bond and write that double bond on 2 carbon atoms with what double bond like this, CH3CHO. One is benzaldehyde, other one is acetaldehyde. This is benzaldehyde, whereas this is acetaldehyde. Next, CH3CHC, here 1 mole is acetone and other mole is what? Acetaldehyde is the compound. CH3CH, and next one is what? CH3CH3. Then the compound formed is CH3 C double bond OH plus CH3 double bond O. Double bond O. Next, this compound let us consider. Here we'll get CH3 double bond O, and here also double bond OH. Next, oxidation with CrO2 Cl2 in the presence of CH2 Cl2, that is chromyl chloride we can say. In this case, 2-methyl pent-1-ene when reacts with CrO2 Cl2 and CH2 Cl2, the compound formed is, wherever double bond is there, oxidation takes place. The double bonded carbon is converted to aldehyde group. So here total we have 5 carbons, and whatever this CH2 group is there, that CH2 group is converted to CHO group. So remaining groups are as it is. This is methyl group. So name of this compound is 2-methyl pentanol. Just CH2 group is converted to CHO group. Means alkenes are oxidized to aldehydes. Same way here 2,3 dimethyl 2-butene when reacts with same reagent, then the compound formed is. See here, one methyl shift is taking place, and one of these that is sp2 hybridized carbon is converted to carbonyl group. That is, in the case of 2,3 dimethyl butene, double bond is not on the terminal carbon, it is in the center. So central alkenes will give you ketones. Then this is the compound CH3. So this is 3,3 dimethyl butane 2-one is the product. Next, hydroboration oxidation reaction. This hydroboration oxidation reaction, we know alkenes generally unsymmetrical alkenes reacts with diborane in the presence of tetrahydrofuran will get tri-propyl borane is formed. This an oxidation with H2O2 propanol is the product. That propanol reacts with an oxidation in the presence of PCC CH2 Cl2. Aldehydes are the product. That is propanol is the compound. Same way here one compound is given. That compound, that is methylene cyclohexene, when it reacts with B2H6 in the presence of tetrahydrofuran, then the product formed is, we know this is converted to CH2, how many moles? 3 moles. B, same like this compound, which on reaction with H2O2, that is oxidation in the presence of a base NaOH, converted to alcohol, that is CH2OH. This CH2OH in the presence of PCC, that is pyridinium chlorochromate, CH2Cl2, will get aldehydes. Sorry, this is not benzene, they have given cyclohexane only. So this is the compound, right? So cyclohexane, name of the compound is cyclohexane carbaldehyde. So this is the final product, which is a carbonyl compound. Next, from alkynes by hydration reaction. So in hydration reaction, what happens? Acetylene, this is ethine, which is also called as acetylene. On hydrolysis in the presence of HgSO4 333 Kelvin, in the presence of diluted H2SO4, will get vinyl alcohols, that is CH, H, double bond C, H, OH. So this is vinyl alcohol. So which is unstable compound, and it undergoes tautomerism, that is tautomerism. It tautomerizes into carbonyl compounds. How we know? See, once I'll write this mechanism here itself. So whatever this OH group is there, that is CH3 CHO, right? So here the bond between O and H, this is shifted, that means this hydrogen is eliminated as H plus. Then this double bond is shifted to this carbon. Here you will get negative charge. That hydrogen will attack on this. Then CH2 becomes CH3, and here CHO group is there. So this is acetaldehyde. Acetaldehyde. Next, same way, let us see propine. So this is propine. Propine on hydrolysis in the presence of same HgSO4, first it is converted to CH3 C, here OH, double bond CH2. So this is also unstable compound. It tautomerizes to carbonyl compound. Which carbonyl compound here? acetone is the carbonyl compound, CH3 C double bond O CH3, right? So whatever here OH bond is there, this OH I'll write like this, OH. Now this bond is shifted between carbon and oxygen, then double bond is shifted to CH2, here minus. This bond broken, H is removed as H plus, that attacks on CH2, then that becomes CH3. On the center carbon there is a double bond, this is acetone. Same way in the case of 2-butene, this is 2-butene, or we can also write but-2-ine. This 2-butene reacts with water and will get CH3C double bond O CH2 CH3. So this is the compound. This is butane 2-one. Ketones are the products from Grignard reagent. So related to Grignard reagent, we did many questions, right? So Grignard reagent when reacts with hydrogen cyanide, that is HCN, then the compound formed is RCH double bond NMgX. This undergoes hydrolysis, forms carbonyl compounds. Let us see how hydrolysis takes place. I'll write here hydrolysis. First, here hydrolysis, here HOH is added. 2 moles of H2O we have taken, right? In the second mole, OH2. Because of this, what is the compound form? Here NH3 molecule, and this part is aldehyde, and this is MgOHX, right? Now I'll write one equation. For example, if you are taking CH3 C triple bond N, right? This is nothing but what? Methyl or ethyl cyanide, you can say, which reacts with R. In place of R, let us take one alkyl group, CH3 Mg. Let us take iodide. Okay, we know this is carbon ion, this is Mg plus. Now this carbon ion will attack on the carbon, then triple bond shifted to nitrogen. Nitrogen will get negative charge. So the compound formed in this reaction is CH3 C above CH3 double bond N, next Mgi. Now here hydrolysis will take place. How many moles? 2 moles of water is added in this reaction. The first mole is like, see here, HOH. Second mole is OH2. Then the compound formed is CH3 C double bond O CH3. That is this part. Next, along with this, ammonia NH3 plus MgOHI. So the compound formed in this reaction is acetone, which is a ketone. So we can prepare both aldehydes and ketones. Now with esters. So esters, Here I have taken ethyl formate. When reacts with Grignard reagent in the presence of dry ether, then the compound formed is what? Intermediate is formed. This is undergoing hydrolysis. Same way, right? Then we'll get carbonyl compounds. That is aldehyde is the product in this. So how the reaction takes place? Let us see. Here I will add water molecule HOH. 2 moles of water is added, right? 1 more mole is added at this place. That is, you can write it as He2H5OH. That is CO C2H5 HOH. So minus ETOH, ethyl alcohol, is eliminated from this molecule like this. 2 moles of OH is on the same carbon, so they are unstable. That's why removal of H2O takes place. Again here minus H2O takes place, which leads to formation of aldehyde. That I'll explain in the second reaction. I'll take an example as let us see CH3 C double bond O ET. This is nothing but ethyl acetate. This ethyl acetate reacts with CH3 MgBr in the presence of same reagent. Then the compound formed is CH3C. We know that how this will attack on the carbon. Minus, this is plus, it will attack on the carbonyl carbon. This bond is shifted to oxygen, it will get negative charge. Mg attacks on this group. Then the compound formed is OMgBr, and here CH3, and this side OET is there. Now this compound on hydrolysis, 2 moles of water is added, removal of ETOH takes place, minus ETOH. Then the compound formed is what? Acetone, CH3 C double bond O CH3, right? This is acetone. Next, reaction with, that is Grignard reagent reacts with the halides, acid halides and acid anhydrides. So this is minus plus. When for this is methyl magnesium bromide, when reacts with the what acid chloride, that is HOS, that is formyl chloride, you can say. This is formyl chloride. Then we'll get an intermediate, which on hydrolysis we are getting acetaldehyde, plus along with acetaldehyde byproduct is MgCl2. Okay, anyway, this is acetaldehyde is formed. Acetaldehyde is formed. Same, if acetyl chloride is taken, then the product formed in this reaction is, that is CH3 OMgCl, and here it is CH3 Cl is the compound. This on acid hydrolysis H3O plus, I'll write. Then the compound formed is acetone. Same mechanism like above one. Next, acid anhydrides. For example, acetic anhydride, if we consider here, this is CH3, this is also CH3, this is nothing but anhydride, acetic anhydride, acetic anhydride. when acetic anhydride reacts with Grignard reagent, the product formed is CH3 COMgCl, and this is what? CH3 OCO CH3. On acid hydrolysis, acetone is formed. This is ketone. Next, reaction with arthoesters. So this is important. Reaction with arthoesters. Now in this case, methyl magnesium iodide, when reacts with ethyl arthoformate in the presence of dry ether, what happens? Removal of MgIOET takes place. This compound is eliminated from the molecule. Then we'll get CH3 CH. Now what happens? Now this CH3 will attack on CH group. So it becomes CH3CH OET OET. Right. Now this compound on hydrolysis with 2 moles of H2O in the presence of H2O, what happens? Removal of ethyl alcohol takes place, minus ETOH. ETOH, that is 2 moles are eliminated from this molecule. Then the compound is CH3CHO. Right? How this reaction takes place, we know. First, what happens? Hydrolysis. Hydrolysis means CN HOH. HOH. Here also HOH. So intermediate was 2 OH groups are on the same carbon. Removal of H2O takes place. Then we'll get finally aldehyde is the product. 2 OH groups present on the same carbon are unstable. Just previously only we discussed. Then which gives you carbonyl compound, that is acetaldehyde is formed. Same way, let us see methyl magnesium iodide when reacts with ethyl artho. This is what ethanoate. Ethyl artho ethanoate. First one is formate. Now, in the presence of tetrahydrofuran, on heating, removal of which one takes place? Removal of, that is minus Mgi and OET. Then the compound is, we know this is minus, this is plus. So in this case also removal of this molecule is taking place. Then CH3 will attack on the CH carbon. Then the compound is CH, like this, I'll write CH3 OET, that is ethoxide. So in the presence of acid, removal of ethyl alcohol takes place. Then the compound formed in this reaction. See, again what happens in this H2O hydrolysis means HOH, addition of water. then the compound gives CH3, CH3, OH, OH. So this is unstable. Why? Because of presence of two same OH groups on the same carbon. Then removal of H2O takes place like this. Then the compound is CH3, C, CH3, double bond O. This is acetone, which is a ketone. Next, Rosenmund reaction, very important reaction this is. So in this Rosenmund reaction, acid chloride, this is acid chloride, reacts with the hydrogen in the presence of PdBaSO4 and sulfur, boiling xylene also. Then the compound forms are aldehydes, right? So generally aldehydes are prepared by this method, not ketones. RC double bond O H plus HCl. So this is aldehyde. Ketones cannot be prepared by this method. Let us see one example. Acetyl chloride, when reacts with hydrogen, same reagent is taken. Then the compound formed is CH3C double bond OH. This is acetaldehyde. So here I gave ketones cannot be prepared by this method. Next, acid chloride even reacts with the lithium tri-tertiary butoxy aluminium hydride, which is also represented like this, LBAH, right? Then we are getting aldehydes. The products are aldehydes. So here let us see, even carbonyl compounds also can be prepared by NaBH4, which is a reducing agent. Along with that, dibol also we can use. Dibol. What is dibol? Dibol is nothing but diisobutyl aluminium hydride. Diisobutyl aluminium hydride, which is also reducing agent. Okay, which reduces esters. Generally, esters can be reduced to aldehydes. Along with that, alcohol is also formed in this reaction. Okay. Next, let us see preparation of what you call ketones. Okay, from acid chloride. So here acid chloride, that is RC double bond OCl, acid chloride reacts with dialkyl cadmium. This is called as dialkyl cadmium. When dialkyl cadmium is used exclusively, we are getting ketones. So this is ketone. In the previous, first one, only aldehydes we prepared by using Rosenmund reaction, but here only ketones are prepared. Okay. Now along with that, CdCl2, that is cadmium dichloride, is formed. Now I am taking one example, that is acetyl chloride. When reacts with dimethyl cadmium, then the compound formed is what? 2 moles of acetone is formed. CH3, CH3. Then CdCl2 is formed. Same acyl chloride, for example, CH3, COCl, when reacts with the diethyl cadmium, if you consider diethyl cadmium, then the compound formed is CH3, C double bond O, C2H5. That is ET I am writing, CdCl2. This is 2-butanone. 2-butanone is formed. Right. Not only this, even aromatic ketones also we can prepare. Let us see that reaction also. That is C6H5 C double bond O Cl. This is called as benzoyl chloride. This benzoyl chloride reacts with CH3 taken twice CD, then C6H5 C double bond O CH3 2 moles plus CdCl2. This is acetophenone. Aromatic ketones are formed in this reaction. This is also one of the important reaction you can say. Now one more named reaction, that is Stephen's reduction reaction. In Stephen's reduction reaction, cyanides are reduced in the presence of tin chloride to carbonyl compounds. Now let us see in this what type of reaction is taking place in Stephen's reaction. If you see, so RCN, that is alkyl cyanide, in the presence of tin chloride and dry ether, imines are formed. First formation of imine takes place. RCH double bond NH dot. HCl is also there. I am writing that also HCl. This is imino hydrogen chloride, you can say, or imino chloride also we can write. Right. This imino chloride on hydrolysis in the presence of acid will get aldehydes. Along with aldehydes, you can also get ammonium chloride salt. So we want aldehyde. Next, let us see one example. Methyl cyanide, when reacts with hydrogen in the presence of SnCl2, that is addition of hydrogens takes place. Then the compound formed is CH3 CH double bond NH HCl, which on hydrolysis in the presence of an acid, then the compound formed is what? CH3 C double bond O H. Acetaldehyde is formed. Along with acetaldehyde, ammonium chloride. Next, reaction with dibal. So here dibal is nothing but cyanide, methyl cyanide. When reacts with dibal, imines are formed. CH3 CH double bond NH. Once imines are formed, they undergo hydrolysis and forms aldehydes. That is, I have taken CH3, so CH3 C double bond O H, acetaldehyde plus ammonia. Acetaldehyde. Now one more compound let us see, that is hexafluorine 1-nitrile. This is also reacting with dibal in the presence of what? H2O. Then the compound formed is, see, this dibal is a reducing agent which reduces cyanide group to the carbonyl group, that is aldehyde group, but not reducing the double bond. So wherever double bond is there, that is not disturbed. Then CH3 CH double bond as it is, CH, then CH2 CH2 cyanide is converted to aldehyde group. Okay, so CH2 CH2 CHO, this is called as aldehyde. What is the name of this compound? Hex 4-ene 1-al. Next, another compound, let us see, ethyl undecanoate. So here also, whenever we add a double, that is a dibal in the presence of water, we are getting what? Carbonyl compound, that is aldehyde. Means here this will cleave, right? HOH, that is HOH, then CH3 CH2 taken 9 CHO, right, plus ETOH, ethyl alcohol is formed. The compound formed in this reaction in undecanol. Undecanol is the product. Next, from acetoacetic esters. So only ketones are formed, that is prepared from this reaction. Now the acetoacetic ester, if you take like this, on hydrolysis the bond will cleave at this place, right? Then addition of water takes place like this, HOH. Then the compound is CH3 C double bond O CH3 plus carbon dioxide plus C2H5OH. Ethyl alcohol is formed. Now what is the carbonyl compound formed here? Acetone. Acetone is formed. Same way, let us see this reaction, that is CH3 C double bond O CH3 COO. Here also, where reaction, addition of H2O takes place, first CO2 elimination takes place like this, then here hydrogen is added, here OH is added, CH3 C double bond O, here CH3 is there, right, CH3, then CH2 CH3, C double bond O CH, right, CH2, that is. Next, CO2 plus ETOH, ethyl alcohol. Ethyl alcohol, CH2 CH3, right? So this is the compound. Name of this compound is methyl, alphabetical order, methyl ketone. Next, OXO process. This OXO process is used only for the aldehyde preparations and which is following anti-Markovnikov rule. So in this, alkenes, when reacts with carbon monoxide and hydrogen in the presence of tetracarbonyl cobalt at 373 Kelvin and at pressure, the compound formed is C1 R CH H CH2, and addition of this CO takes place like this, and aldehydes, that is carbonyl compound is formed. This is aldehyde. Right, let us see one reaction. Right, CH3 CH double bond CH2, let us consider this is propane. when it reacts with carbon monoxide plus H2, then the compound formed is CH3, CH2, CH2, CHO. Right? So that is nothing but what or else isomeric product also we can expect CH3, CH, CH3 and CHO. This is the product formed in the OXO process. Next, Wacker's process. In Wacker's process, alkenes. So here I have taken ethene, which reacts with the palladium dichloride with water in the presence of CuCl2. The compound formed is aldehydes. That is CH3, CHO, acetaldehyde plus palladium. Then what is left? HCl, 2 modes. Same way, for example, if we take propene, propene can be converted to acetone. CH3, C double bond O, CH3 plus PD plus HCl. Next, let us see preparation of aldehydes and ketones from alkyl halides. In this, primary alkyl halides gives aldehydes, secondary alkyl halides gives ketones, whereas tertiary alkyl halides are not giving any products. That is, no reaction is taking place, right? Generally, this reaction is taking place with the dimethyl sulfoxide, haprotic solvent. Let us see some examples. That is, for example, CH3, CH2, Cl when reacts with CH3 taken twice SO, di-DMSO, methyl sulfoxide. Then the compound formed is CH3, CHO plus CH3 taken twice S plus HCl, hydrogen chloride is formed. So here we got acetaldehyde. Acetaldehyde is formed. Same way, let us consider secondary alkyl halide CH3, CH3, CHCl plus dimethyl sulfoxide. Then the product is ketone, remaining as it is. Next, tertiary let us consider. That is C, no reaction. Next, let us see aldehydes and ketones from cadmium and lithium salts. Cadmium and lithium salts, let us see. So in this, first what happens, Grignard reagent reacts with cadmium chlorides, then we'll get dialkyl cadmium. So that dialkyl cadmium again reacts with acid chlorides, forms ketones. So that is the mechanism taking place in this reaction. So let us see one reaction, that is RMgX when reacts with cadmium chloride, then we'll get R2CD. That means 2 moles of RMgX you have to take. plus MgCl2 plus MgX2. So whatever this dialkyl cadmium is formed here, this dialkyl cadmium R2CD reacts with acid chloride RCOCl, gives ketone. For identification, I'll take R dash, then here I dash, R dash plus RCDCl is formed. So this is ketone. Got it? Right? So generally, even we can also prepare what aryl carbonyl compounds, right? So one reaction, let us see, that is lithium salts of carboxylic acids, right? Generally used in the carbonyl compounds. First, lithium salts of carboxylic acids reacts with lithium, that is methyl lithium, then we'll get an intermediate product, that is RCOOLi minus, and this is plus, reacts with methyl lithium. Then the compound formed is RCOHOLi, then CH3 is taken, right? So this is the compound form. This on hydrolysis, in the presence of acid, removal of LiOH takes place. Because of that, the compound formed is what? RCOH CH3, this becomes OH. Now from this, two OH groups are on the same carbon, removal of H2O takes place, which leads to formation of ketones. So these are the some methods of preparations of carbonyl compounds, aldehydes and ketones. Now aromatic aldehydes and ketones also we can prepare, that also we'll discuss.